Last one for material approach to the market is bio-based polymer. These days, everybody approach with this kind of same ways. Rhodia, we are producing 610 based on conventional ways. From oils, we make the 610. But this time, we are putting some castor oil originated materials with a half-half. Okay, roughly the ratio is half-half with the HMDAs. So the difference is we are putting sebacic acid from castor oils to make some part with our own technology, showing different mechanical properties, showing different chemical resistance against conventional 610 materials. So this slide is showing the comparison test between our own bio-based 610 and also conventional 610 and 612, polyamide 12 and normal polyamide 6. You may see that here, I just wanted to ask you to look at this comparison between 610 between the conventional one and our Rhodia one. Surely our one is showing the better mechanical properties and impact properties as well. Compared to 612 and the polyamide 12, it has showing the very nice temperature resistance because of the inherited characteristic itself. We developed this bio-based product, so several for meeting several different type of the viscosity materials, especially high viscosity materials for extrusions, some injection grade with glass fibers, and those unreinforced product for specialty, some industrial purpose. Application is sometimes very similar with Alchema. Just he presented the people like some application for automotive, like the air brake systems, fuel system like quick connectors, even the radiator water tank for calcium chloride resistance, and also it can be used for the different industries, hydraulic and pneumatic and systems. Also some our daily life. You can easily contact some batteries. Battery they need more higher chemical resistance, but which should bring some low cost. Okay, this is the last offer to the market. This is not our solution. This solution is not based on our product offer itself. Solution is how to support customer when customer make the designs. Normally, customer they want a structural part which should resist at a certain load. So most of customers they are making computer simulation to anticipate, to predict the behavior of part itself on the certain node. So they are making such simulations based on the mold flow and some structural analysis like Abacus or ANSYS, something like that. But Rhodia, we are providing a little bit different solutions which after consideration of the glass fibers. You know, the glass fiber is a common fillers which increase mechanical properties with the polymer itself. So most of application polyamide, they are using glass fiber. So we should consider the glass fiber impact. What is the real factor which decide the material properties? Very simple example. When you made some specimen based on glass fiber angles, one question is, for example, if we made some specimen at the angle perpendicular angles like the 90 degree. Surely this specimen showing in terms of tensile strength is showing the very long elongations properties, but it has very less mechanical properties. We can stress. But if we cut a specimen at 45 angles, it's showing the less elongation properties, but better mechanical properties, depending on the glass fiber directions, orientations. Of course, if we cut specimen at the flow area, flow directions, surely it's showing the good mechanical properties, but less elongations. Depending on the glass fiber orientations, definitely the behavior of the part, behavior of each part showing different mechanical properties. Rhodia, we consider this kind of glass fiber impact based on our polymer characteristic for several hundred of the grade together. So for each glass fiber angles, it's showing the different one. Not only the glass fiber orientation, but also the we need to consider about that skin layers and core layers. It's also showing the different glass fiber orientations. So we made a whole this kind of database to apply to make the system which can anticipate or predict more clear or correct behavior of the part characteristic itself. So we call it, this is MMI. MMI is a multi-scaling modeling for mechanical calculations with the injection molding simulation together. We call it internally Rhodia side, we call it MMI. With these MMI solutions, I can show you the very simple examples. This is some simulation impact, simulation case result. This application is hood inner under the bonnet. There is some plastic part. There is some test with the ball. This kind we call it the ball drop test. With conventional simulations, with such kind of ball drop on the ball drop test, normally this part does not showing any break happens. But when we make the real part test, actually this part is showing some break. So we make the real calculation after the consideration of the glass fiber orientation. In this slide is showing the glass fiber orientation at each area of the part itself. I'm not so sure you can identify the glass fiber, which is very small in these pictures. After this one, showing this part, this is our MMI simulations, is showing the real part break. This is kind of high-speed camera. We already took with this kind of one. You may see it. Okay, so this is a difference between the conventional structural analysis and our own offer to the automotive markets. This one is showing little bit our internal experiment test result. It's dotted line showing actual part test result done by customer at their laboratories. And also this green color showing our simulations result with the normal one. But you may see there is some difference between the green color and the dotted lines, because this is a real difference between the conventional simulation and the part test. But our MMI is showing almost coherent test result based on the real part test. So showing this kind of simulation really reduce customers' investment. For example, customer can sometimes skipping the prototype process. Also, they can reduce some sickness to avoid, some frustration of the broken part of the part, broken area of the part. So this slide is showing some standard comparison between top area is standard simulations, bottom areas are the Rhodia own developed softwares. Okay, so conclusion of my presentation today is we are providing some different solutions. First, we provide to the market to meet the automotive demand composite materials. Secondly, we are providing also some fuel contact materials which can avoid high investment on the customer side. Also bring them more productivities. Third one is we are providing also bio-based materials which can replace little bit higher cost materials. Lastly, it's not a material solution. Our simulations or the application and technical support to customers to reduce